Okay, I'm back. Sorry about that. There was just this unexplained ringing noise in Fondren, and I thought it was an alarm telling us to evacuate. Okay, so we're currently at this line right here in the code where we decided that f of x is greater than tolerance, so that ends up evaluating to be true. So what a while loop does is whenever the logical statement to the right is true, it will run the code under that. And then but the difference between a while loop and if is that whenever it finishes, it goes back to this thing, back to the beginning where it says while an if loop or an if statement essentially doesn't. So this is why a while loop is a loop, because it goes down, it finishes, and then it goes back and basically starts again, and then basically runs like another if statement. So if f of a times f of x is less than 0. So what's f of a? So f of a is minus 3. F of x is minus 0.44. So minus 3 times minus 0.44 is equal to 1.32. So since that's not less than 0, then we're going to set b to x. So the value of b is now set to the value of x. X was 1.6, so b is now 1.6. And then this else gets ignored because the if statement was it wasn't ignored. I did the wrong thing here. So since this ended up being false because it is greater than 0, then it goes through the if and goes to the else. And in this else statement, it then sets a to x. So instead of setting b to x, b is still 3.2. And a is now 1.6. Okay? So yeah. Now we have that. Here it then redefines x to be a plus b over 2, which now evaluates to 2.4. Okay. So once it reaches this end, it then loops around and starts again on the while loop. So while absolute value of f of x is tall, so x is 2.4, I'm just going to complete this all very quickly. F of x is equal to 2.76, and that is greater than our tolerance of 0.1. So we end up getting this to be true, so it continues with the code. F of a times f of x is less than 0. It turns out that f of a is equal to minus 0.44. F of x is equal to 2.76, and whenever you multiply it, you get like something around like 1.1, and of course minus 1.1, and that ends up being negative, so this ends up being true. So it sets b to the value of x, so b is now 2.4, and x is going to be redefined because it skips the else if this ends up being true, right? Because else is if this ends up not being true. And so it then does x is set to a plus b over 2, which in this case would be 2.0. All right. So now we can keep on walking and go back up to this while loop. While f of x is greater than tall, so here f of x is equal to 1, and that is bigger, an absolute value is equal to 1, which is greater than 0.1. That's true, that means we keep going. We then do this product, and f of a is equal to 256, or minus 0.44. F of x is equal to positive 1, so that ends up multiplying to be minus 0.44. Since that's less than 0, then we're going to set b to x. And so what that'll do is that'll change what b is. So b changes to 2.0. Okay? And then this else gets ignored because the if statement was true, and that x is then set to a plus b over 2, which in this case would be 1.8. Okay? So now we are going to go back to this while loop, evaluate whether or not this is true, which with this 1.8 will evaluate to 0.24, which is greater than 0.1. And then it'll go to this if statement. It'll do f of a times f of x. Is that less than 0? So f of a is equal to minus 0.44. F of x is equal to 0.24. And whenever you multiply it, you would get like, something positive, actually 0.1008, or negative 0.1008. And so, wait, no, that's wrong. Negative 0.1056, but whatever. Thought it was 0.42. But it's still less than 0, so this ends up being true. B is set to be x, so the new value of B is 1.8. 1.8. My marker is getting really bad. And then the value of x is then set to a plus b over 2 because the else statement is ignored. So x is now 1.7. Okay, we then evaluate this while loop. F of x is great. Absolute value of f of x is greater than tall. Absolute value of f of x is equal to 0.11 because f of x is minus 0.11. So that is bigger than our tall of 0.1. So we then can do this step. F of a times f of x is less than 0. And f of a is equal to minus 0.44. F of x is equal to minus 0.11. That does multiply to positive 0.0484, which is greater than 0. So this ends up being false. So the else is run. So a is set to x. A is now 1.7. And it reaches this end. Then x is set to a plus b over 2, which is 1.75. Okay, then we go back to this while statement. While absolute value of f of x is greater than tall, and actually when you compute f of x, it'll end up being positive 0.0625, which is actually, when absolute value is 0.0625, which is actually less than our tolerance. And so this ends up being false. So what while loops do when this ends up being false is they exit the while loop, like in this block of code, don't run it again anymore. This else is ignored because this evaluated to be true, and it ends. So what we end up at the end is our answer of x equals 1.75 for our result. So of course the root to this equation, y equals x squared minus 3, is the square root of 3. And this is actually pretty close. Square root of 3 is actually like 1.732 something. So that's how you compute the square root of 3 using bisection. I think this ended up using like 5, maybe 6 steps, depending on how you count it. But yeah, that's a fully worked example of bisection. Okay, I guess that's it. Bye.